So this thing, the reciprocal, we're going to be using it a lot now and in the future, so we should be aware of some of its properties. The first and most obvious property of the reciprocal is, if I take the reciprocal twice, I end up back where I started. So if I have the fraction 5/9 and I take the reciprocal, I get 9/5. If I take the reciprocal again, I get 5/9 back. There are a couple of other easy to see properties. The reciprocal of a proper fraction is improper. If I start with 5/9, take the reciprocal, I get 9/5. Right? If I start with a fraction whose numerator is smaller than its denominator, take the reciprocal, I'll end up with a fraction whose denominator is smaller than its numerator, of course. The reciprocal of an improper fraction bigger than 1 is always proper. What about 1? The reciprocal of 1 written in any form is just 1. Right, so that means 1 over 1, it's easy to see as its own reciprocal. 9 over 9, 17 over 17, etc. Since 1 always has its numerator equal to its denominator, nothing changes when I swap them. The last obvious from looking property is the reciprocal of a whole number is a unit fraction, that is, 1 over some number. The reciprocal of a unit fraction is just a whole number. So if I take some number of wholes and take its reciprocal, I get 1 over that number. Take the reciprocal the other way round, I get some number of wholes over 1. This actually has a consequence for division that's interesting though, right? Dividing by a whole number is just like multiplying by a unit fraction. So dividing by 2 is like multiplying by a half. Or, maybe more interestingly, multiplying by a half is like dividing by 2. The other way around also. Dividing by a unit fraction is like multiplying by a whole number. So, for example, dividing by a third is multiplying by 3. All right, this is mildly interesting. Nothing too spectacular so far. 0 has no reciprocal. If it did, that number would be a fraction with 0 in the denominator, which isn't a thing. All right, now here's the really interesting one. Any number times its reciprocal is 1. So 3/7 times 7/3, 9/32 times 32/9, 84/10 times 10/84, whatever. Any number times its reciprocal is always 1. Right, and we can see that. All right, that's not a big deal. What's a bigger deal is what this implies. For any number except for 0, there's something we can multiply it by to get 1. What's the something? Well, it's reciprocal. This turns out to be a really big deal. This is really nice. Why? What's so special about 1? Remember we said that 1 was the multiplicative identity. Multiplying by 1 doesn't change anything. We call this number that we can multiply by to get 1 the multiplicative inverse. We understand the two numbers to be somehow opposite with regard to multiplication. But this idea, the fact that there's a number that's opposite with regard to multiplication, in a sense, this kind of turns our whole notion of division around. In a sense, division is just multiplication by the inverse. Division isn't the opposite of multiplication. It's multiplication by the opposite. Does that mean we can throw away all of our ideas of procedures for doing division? No, not at all. But those procedures, the reason they're so screwy is that they really are just winding the procedure for multiplication backwards. So there's a very real sense in which division really is just multiplication done backwards.